Hi guys, so here's another video, still doing cubic functions, we're still here, that's okay. What I'm going to do, I'm going to go through an example where you're going to only be given one root. So I've gone through an example where you need to find just a number where most of it's expanded or factorized already. You need to find one value. We've gone through an example where you need to have where you're given two roots. Now in this example, you're given one root. Okay, so I'm going to use our information and our knowledge from before to apply it to this example here. Now this one is a bit harder, so please make sure you're paying attention. Have your thinking caps on to be able to do this one. Okay, so find the roots of the cubic function x cubed take 5x squared take 9x plus 45, given that it passes the x-axis at 5, 0. So I'm going to basically put my expanded version on one side, and I'm going to put my root in a factorized form. Now remember, our factorized form is ax take b, x take c, x take d, where b, c, and d are roots. Now I've mentioned before, I know a is going to equal 1 because the coefficient of x cubed is 1, so I'm going to actually get rid of that, so don't worry about it. So let's see if we can work out everything else. I'm going to substitute one of my roots in for b. For b and c, I'm going to actually use the expanded form here. I'm just going to write it slightly differently to help us out. So I'm going to actually write it here. So I'm going to write x take 5 and then an expanded version. And remember, b and c are just letters. They're just like numbers. Don't worry about what letters I've used here. I've just kind of just chosen any letters. All right, so don't worry about all this bit, okay? So let's see if we can actually work out what this is. I'm going to expand what I can from this. I'm going to expand the x out, and I'm also going to expand the 5 out. Okay, I'm going to give myself some room because I know it's going to take a lot of space. So let's do that. So I'm going to expand my x. X times x squared is x cubed. X times bx is bx squared. X times c is cx. Negative 5 times x squared is negative 5x squared. Negative 5 times by bx is negative 5bx. And then negative 5 times by c is negative 5c. Okay, I'm going to actually collate like terms together. Probably haven't done like terms in a little while. But we're going to put our x cubed terms together where we only have one. I've got two bx terms here, right? So I've got bx squared take 5x squared. Now I can factorize that to equal b take 5x squared. So I'm going to use that in here. So I'm going to write plus b take 5x squared. All right, I'm going to do my next bracket as well. I'm going to go, well, these ones are the same. So cx take 5bx are like terms, which can be rewritten as c take 5b. That's the factorized form. X, I'm going to write that here. And then I've got 5c on its own. Okay. Now, because this is still continuing down, the coefficient of x squared is going to be equal to 5b. The coefficient of negative 9 here, coefficient of x is equal to c take 5b. Okay, so, and then that's going to help me find out that, oops, I've used the color already. I've also got this one here, 45 is equal to negative 5c, which we don't entirely need because we already have these two to help us find out what b and c are. The blue one can be used as like a checking tool. So let's make the yellow ones equal to each other because they're both coefficients of x squared. So negative 5 is equal to b take 5. If I add 5 on this side here, I'm going to have 0 is equal to b. Now my next one here, I'm going to put my green ones together. Negative 9 is equal to c take 5b. I know what b is equal to 0, so I'm going to write c take 5 times 0, which is 0. So c is equal to negative 9. And if I double check here, if I use my blue to double check, c is equal, negative 5c is equal to 45. If I divide by negative 5, c is equal to negative 9. So that's a good way to check that that's right. Okay, so we're going to substitute that in. So therefore, y is equal to x take 5, x squared. Now my b is 0, so 0x squared. Oh, sorry, no, just 0x. And then my c is equal to negative 9. Like that, which can be rewritten as this here. Now, I want to write this in turning point form. I'm not turning point form. I'm going to write it in root form. So this x squared take 9, it's like the difference of perfect squares. So I can actually write this as x take 3, x plus 3. Okay? So I'm asked to find the roots. So therefore my roots are at 5, 0, 3, 0, and negative 3, 0. Alright, there was quite a few bits and pieces there. Let me just quickly run through what we've done so that way you have a better understanding. So what we did was that we made the expanded version this equal the factorized version, and I had one bracket sorted, so I did one bracket already. So I did this from here, and then I had the x squared plus bx plus c to help me figure out my coefficients for x and the constant. So I expanded that out, and I actually matched the coefficients from the left and right hand side. So the yellow ones are coefficients of x squared, the green ones are the coefficients of x, and then the blue one represents the constant. And from that, I was able to find out what b and c are equal to. Once I found b and c, I substituted it back into the original factorized form, and I simplified it. And then because x squared take 9 is a difference of perfect squares, I was able to factor it out again to figure out what my roots were. And now that my rule was given in root form, I was able to work out the roots.